Have you ever stopped to imagine how much energy the sun gives off throughout its 10 billion year existence? Now imagine all that energy and more being shot out in a matter of seconds. Welcome to the world of gamma-ray bursts, the universe's most powerful, silent killers. These explosive events, triggered by the most extreme phenomena in the cosmos, are not just awe-inspiring spectacles, but harbingers of destruction on a cosmic scale. Join us in today's video as we delve into the mind-bending science behind GRBs and the apocalyptic power they hold. Before we comprehend gamma-ray bursts and how powerful they are, we first need to understand what gamma rays are. Gamma rays are a form of electromagnetic radiation, much like visible light, infrared, ultraviolet rays, and radio waves. But gamma rays have a much higher energy than all the rest. Compared to visible light, gamma rays are 1 million to 1 trillion times more energetic and hence more powerful. Gamma-ray bursts, or GRBs, are extremely powerful cosmic explosions that form from the violent explosion of a dying star as its core collapses on itself. GRBs have been observed in distant galaxies, billions of light-years away, and yet their radiation is still picked by satellites on Earth, making them the most luminous and energetic explosions in the universe. They can last anywhere from a few milliseconds to several hours. Unlike supernovas and other types of cosmic explosions, gamma-ray bursts shoot out as jets of plasma energy, centralized like a laser traveling at nearly the speed of light. These plasma jets of gamma rays are extremely bright and powerful, producing as much energy as the sun will emit in its entire existence. This makes them easy to detect, even from billions of light-years away. It might surprise you at just how we detected the first gamma-ray burst. Scientists weren't exactly studying the stars to unlock the mysteries of space, but it was actually the United States spying on other countries with satellites from space. This was back in 1963, after signing the Nuclear Test Ban Treaty. The United States wanted to ensure the other nations kept to the treaty, so they launched satellites to spy on them. The satellites were meant to pick up spikes of gamma rays on Earth, which would indicate nuclear launch tests, but instead, the satellites found bursts of gamma rays from deep in outer space. These gamma rays weren't from aliens making nuclear bombs, but were our first recorded encounter with the most powerful and dangerous explosions in the cosmos. Scientists initially thought these GRBs exploding in distant galaxies would destroy all life in that galaxy based on how powerful these bursts of energy were. But upon further study, they discovered that however powerful these bursts of gamma rays were, they didn't detonate like bombs, but instead channeled their energy into two narrow beams like lasers. This makes them even more dangerous because instead of scattering all that energy over a wide area, they channel it in such a way that whatever is caught in their path would be obliterated in seconds. So what would happen if a gamma-ray burst were to explode in our cosmic neighborhood? Well, one thing is for certain, it wouldn't be good. If a gamma-ray burst were to explode within 200 light-years of Earth and the jets were pointed in our direction, our planet would be vaporized almost instantly. At a greater distance of, say, 1,000 light-years, the gamma-ray bursts would still vaporize the atmosphere on the side facing the explosion. It would strip the ozone layer from that side of the planet, leaving us at the mercy of harmful solar radiation from the sun. Solar radiation would then evaporate our oceans and destroy entire ecosystems long before the atmosphere has time to heal. For context, a supernova would have to be within 50 light-years of Earth to do this much damage, but a plasma jet from a gamma-ray burst would still devastate our planet thousands of light-years away. GRBs from billions of light-years away still cause disruption to radio and satellite communication here on Earth, a testament to how powerful and far-reaching they are. Fortunately, gamma-ray bursts are quite rare and astronomers haven't found any dying stars or potential neutron star collisions within Earth's vicinity that are a cause for concern. Scientists believe these bursts of gamma rays are more common to galaxies currently undergoing radical star formation, a phase that our galaxy seems to have passed a few billion years ago. However, there are still remnants of supernovas, the precursors to GRBs, all over the Milky Way galaxy. These indicate that our galaxy once experienced these deadly bursts just as frequently as other young distant galaxies do today. In fact, scientists believe a gamma-ray burst was most likely the cause of the Ordovician-Silurian mass extinction that took place about 440 million years ago. Ranked as the second most devastating mass extinction event in our planet's history, it is believed a gamma ray burst thousands of light years away, hit the Earth. This triggered a climate action with radical global temperatures kickstarting an ice age that took 85% of all life along with it. So while it is still unlikely that a GRB of destructive proportions will hit Earth anytime in the near future, these bursts reach Earth all the time. Due to their sheer immense energy and speed at which they travel, GRBs from distant galaxies hit Earth all the time, but because they've traveled across billions of light years, our satellites only pick up the faint effects of these bursts, and our ozone layer does a remarkable job of protecting us from them. This is the reason why gamma-ray telescopes are all satellites in space out of the protective barrier of our atmosphere. NASA's vast observatory is tasked with detecting and studying GRBs and detects an average of one each day. So one question is, if these gamma-ray bursts are so bright and powerful, why can't we see them from Earth, or even in our galaxy for that matter? Well, for one, gamma rays are electromagnetic, meaning we can't see them with our naked eyes. If we could see GRBs, our view of space would be truly spectacular indeed, with ever-changing bursts of high-energy radiation spontaneously lighting up the sky even during the day. And while that would make for a spectacular view, it's a good thing we can't see them, not just because we simply can't, but also because that would mean they were close enough to cause damage to the Earth. Studies from the BaseT satellite have revealed that gamma-ray bursts aren't all the same, as they occur in two main forms: short-duration GRBs and long-duration GRBs. As the name implies, the short-duration GRBs only last for a few seconds and typically originate from the collision of two neutron stars. These short-duration bursts of gamma rays are few and far between, as they are not sustainable and do not last long enough to be studied. Long-duration GRBs, on the other hand, account for over 70% of all gamma-ray events observed so far. They emerge from the collapsed core of massive stars, with masses ranging from 5 to 10 times the mass of the Sun. Powerful magnetic fields are charged from the collapsing star, and as it becomes a black hole, these energetic particles are blasted as two polar jets of gamma rays that shoot out at nearly the speed of light. These types of gamma ray bursts can last from a few seconds to a few hours and would be simply devastating to anything caught in its path. One of the brightest and most powerful gamma ray bursts ever detected was discovered in 2022. Nicknamed the brightest of all time, or BOAT, this gamma-ray burst was so bright and energetic, it is believed to have originated from the collapse of a star 30 times the mass of our Sun. The BOAT GRB is arguably the brightest cosmic event ever recorded, and some scientists argue it is only superseded by the Big Bang itself. This GRB was also much closer than others previously detected, almost 20 times closer to Earth than its counterparts, which was still far considering it was a whopping 2.4 billion light-years away. But even at that insane distance, its radiation was so powerful and intense that it briefly disrupted Earth's ionosphere, disturbing radio communications in the northern hemisphere. This simply shows how phenomenal and explosive gamma-ray bursts can be. But regardless of their destructive nature, GRBs have found some use in science and astronomy today. Scientists have found a way to use gamma-ray bursts to study the composition of exoplanets, a feat that was previously quite difficult due to the distance of these outer planets. The chemical elements of rocks and gases emit certain unique chemical signatures when struck by gamma rays, and these signatures can be used to decode the composition of these exoplanets. The data from these studies can help scientists deduce if an exoplanet is composed of base elements like hydrogen, oxygen, sodium, magnesium, and calcium. We can also rule out which planets would be habitable from their proximity to gamma-ray bursts. Scientists have stated that gamma-ray bursts might be the reason we don't see life anywhere else in the universe, as they might be obliterating entire ecosystems before they have a chance to evolve into self-sustaining worlds. It is estimated that because of gamma-ray bursts, only about 10% of all distant galaxies will be hospitable to sustain life. Our galaxy is already so advanced on a cosmic scale, and our solar system is positioned in a region that is free from any dying stars that might threaten a GRB explosion. So once again, the universe shows us why Earth is one of a kind. But then again, gamma-ray bursts move nearly at the speed of light, so we might not know or see them until we are staring down the barrel of a cosmic laser gun. What do you think is getting evaporated by a gamma-ray burst the way we go out? Let us know your thoughts in the comments below, and we'll see you in the next video.